Okay, so it seems I'm alone here, so I guess I can take this off. As I said before, in case you saw the shorter teaser video, welcome to the 7th Automotive Ethernet Congress, where Technica is for the 7th time here, again as a golden sponsor, and as being the pioneers of automotive Ethernet testing, we want to show you how from providing the first tools, 100 base T1, 1000 base T1, we are now having a whole new generation of hardware and software solutions for your testing needs. So now that you are joining us, please remember to reach out to the guys in the booth. They are live there waiting for you to chat and to have video sessions. But in this video, we're going to show you the nice big demo behind me. So please make sure to write your notes, get your questions, and reach out to us to clarify them, because this is what this is all about. All right, so what we've got today is a very big challenge in the automotive industry. As you know, with the introduction of Automotive Ethernet, we have a high bandwidth communication solution, mainly looking at service-based communication that is in here to enhance the communication between electrical control units in general. Of course, legacy, what I like to call legacy communications like CAN, communication technologies like CAN, CAN-FD, FlexRay, and LIN still play a very important part, which is why today we want to showcase the capture module family of devices, and also a couple of other things like the new generation 100-1000 base T1 converters and the enhanced Ethernet switch, which is an AVB capable solution. We'll have some more details on this in a moment. What I want to address at this point are the challenges in the logging of modern automotive networks. So you've got things in your car on the infotainment world, on the telecommunications world, on the advanced driving assistance world, and the new comfort world where higher complexity functions are coming into play. And in this case, you need your electrical control units to communicate with each other with a multitude of communication technologies. When you evaluate, you test and validate those features, those functions, you want to see what happened on each of the communication paths along the way. And with Automotive Ethernet, please don't forget that your testing system will become a part of your network. So essentially, now you're cutting lines in order to look at them if you're talking about Automotive Ethernet. So the challenges for the car maker are very big. You now have an issue with your cable harness. So FlexRay, CAN-FD, they require your stub lengths to be much shorter than classical CAN. You also have the issue that, as I said before, your Ethernet lines, you will need to cut them to have your test validation devices in between to capture that traffic. You also have the issue that in the car, you need those measurement systems, those testing solutions to be to work according to the battery power, the power concept of your car. You don't want them to keep on running overnight and drain the battery. You also want them to start up really quickly. You also have the issue of how to capture all of this high bandwidth traffic, because you need to deal now with multiple gigabits per second of traffic in some cases. And this is a big challenge for today's technologies that we're using. So in order to address these challenges, you need to have reliable systems that build upon a lot of experience, because working with these higher bandwidth technologies is a lot more complicated than doing, let's say, CAN or LIN. And Technica Engineering has been working with this since 2008. We have developed more than 8 different generations of testing solutions. The last ones of those were based on FPGAs. So there is a difference when you're working with Automotive Ethernet. Remember, you have a packet switched network, which means you are going to use switches, Automotive Ethernet switches, which are elemental to make Ethernet work. How do you evaluate that network? You can use switch-based devices such as the Media Gateway or the new EES. My colleague Daniel is going to go into details on how those work. You can use tap devices just to sniff, like the capture modules. And what we are doing here is, since several years, we started experimenting with transporting CAN, LIN, and analog information via standard Ethernet. So that's what the capture modules are doing over here. My colleague Daniel will go into a detail on how we do this, because yes, we're using standard Ethernet as anybody can use, but also how do you tell your analyzing software what is it that it's seeing? So you're going to need some kind of protocol to solve that issue. All of this is addressed here. Also, the software tools that are needed to do the analysis of this traffic. And well, last but not least, Technica Engineering is not only providing testing tools in terms of software and hardware, we are also an engineering company. So we provide testing solutions, complete testing solutions for ECUs. If you want to know about this, this goes a little bit beyond the automotive Ethernet scope. Please reach out to us. The largest amount of Technica Engineering colleagues are working in testing projects. And if you are an OEM and you're new to, or maybe not completely new, but getting into the deployment of architectures with automotive Ethernet inside it, we also provide systems engineering services. We're working with the largest German OEMs, basically north, south, east and west. And also beyond that, several other European and East Asian OEMs. And we're pretty sure that we can give you a lot of help there. If this is interesting, please reach out to us via the chat or the video when it comes to deployment of protocols, selection of do you need AVB, do you need TSN, how do you work with CAN and LIN and so on, and on gateway, the gateway solution of your car, topology questions, and so on. With all this said, I would like to move over to what my colleague Daniel is going to tell you about this nice demo. I hope that you are interested in the things you see, the kinds of connectors that we're using, the kinds of features that the capture modules and the EES, the Enhanced Ethernet Switch, have for you, and the features on the analyzing software as well. So don't hesitate to reach out to us. We are online here for the next 3 days, and we'll be happy to get in touch with you.
Hello everyone, my name is Daniel Popalsai and I'm the Technical Sales Engineer for Technica Engineering. Today I'm here to show you the demo where I give you the insight about the in-vehicle network and how are we capturing the traffic from different types of buses and point-to-point networks. So let's just dive deep into it. On the right hand side, I have capture modules. These are our modular systems that capture the traffic from the vehicle. They come in 5 variants, so we have a variant for every technology. We are capturing traffic of LIN and analog signals. We are capturing traffic from CAN, CAN-FD, FlexRay, and serial communication. And then we are capturing traffic based on Ethernet, 100 base T1 and 1000 base T1. All of this traffic is then logged to our logging system or to our software tool, which is called Andy. We will visualize this traffic using Andy Traffic Viewer, where we will see all this traffic has been captured using one interface on your logging unit. Also, all of this traffic is time synchronized, sharing the common understanding of timing. So let's just dive deep into it one by one. First, I will explain how is this traffic generated. So on my right hand side, I have our software tool called Andy. Andy is capable of enabling the user to write scripts in Python, where you can send trigger signals, you can write scripts to send messages and frames for different types of protocols using Ethernet, using LIN, CAN, and serial communication. And all of this communication is later logged. So on my right hand side, Andy is generating some signals. The traffic generation units are actually being triggered, and then they start to generate traffic. So over here, I have our media gateway. Media gateway is an automotive Ethernet capable switch. Now, this media gateway is actually triggered by Andy, and it starts to send Ethernet-based messages, 100 base T1 and 1000 base T1. And these messages are then logged by the logging part of this demo, which is the capture module. Moreover, I also have a 100 and 1000 base T1 media converter MateNet, which is also providing one interface for 1000 base T1, which is later logged on our capture modules unit. So all of this traffic is being logged by the Ethernet parts of the capture modules. Now for the non-Ethernet parts, where we are triggering LIN, CAN, CANFD, FlexRay, and analog signals, we have these two modules over here. One is called FCCP, Flexible Central Computing Platform, and the second one is called BTS Evo. Both of these modules are talking to one another in different languages like LIN, CANFD, CAN, and FlexRay. And the capture modules that deals with these technologies are actually tapping into this communication, logging it to our logging system. So all in all, over here, we have our traffic generation. So the triggers are coming from Andy, from the scripting tool, and these modules that are capable of generating traffic are actually generating this traffic. Then, on the left-hand side over here, we have our capture modules that are logging this communication. So all the traffic that we generate through Andy is being logged by our 5 capture modules. As I mentioned, we have 5 variants for capture modules. The first one being LIN combo, capture module LIN combo, that logs LIN as well as analog communication. So the triggers or the messages that are being exchanged between these two units are actually logged using capture module LIN combo. Then the second one, called capture module CAN combo, is actually logging CAN, CANFD, FlexRay, and serial communication RS-232. And then for the Ethernet parts, we have 3 modules. So the first one be called capture module Ethernet combo, which is a combination of logging 100 base T1 and 1000 base T1 technology. The fourth one being capture module 100 high, and the fifth one being capture module 1000 high. Now 100 high, as clear from the name, is actually logging 100 base T1 technology. And the 1000 high is actually logging 1000 base T1 technology. Now all this logged traffic is actually aggregated into our next generation switch, which we call Enhanced Ethernet Switch. This is an AVB capable 1000 base T1 switch. So all the traffic is actually received by the Enhanced Ethernet Switch. The Enhanced Ethernet Switch is acting as a central part to collect this traffic and then send using one interface to send this traffic to our logging unit. The logging unit being your PC or your logger, whichever, any device that has enough memory to log all your traffic. The cool part is that you can log all this traffic and visualize it using Andy Traffic Viewer. So all your traffic, no matter if it's LIN, CAN, if it's Ethernet, if it's non-Ethernet, everything can be logged using one interface in one node, and then you can visualize all of this traffic in continuity. This is the first part. The second part is that all of these technologies are actually using time synchronization. They are using the standard 802.1as. That means that all of them have a common understanding of time. So when the logging units, when the logging network is logging all this traffic, all of this traffic is actually sharing the common understanding, and that means when the logger or your logging node is receiving this traffic, you can visualize in Traffic Viewer or Wireshark the common time stamping at what time, which particular traffic from which particular node, from which particular port of that node was received. And this is the beauty of it, because at the end of the day, you are logging all this traffic, chunks of gigabytes of data, and then you know who sent what when. All this information is logged in using an open protocol called TECMP, Technically Enhanced Capture Module Protocol. Now the beauty of this protocol is it can encapsulate LIN, CAN, FlexRay, Ethernet, serial communication, analog communication into an Ethernet frame. This new Ethernet frame has a header which has TECMP information. This TECMP information actually contains the capture module ID, so you know which node is actually sending this information. It also contains which particular port was used to send this information, so the channel ID. It also has some built-in counters, so you know how many packets were received. And moreover, you also have some timestamping information, so you know at what time was this information received. So you cover all your what, why, who, and when of your logging system. And all of this information is captured by your logging node. And then the logging node can make sense of it. So TECMP being an open protocol, Wireshark is also able to understand it, to dissect this information, to decode this information and show it to you. Apart from Wireshark, you can also use our inbuilt tool called ND Traffic Weaver, which can give you additional information and more control over logging this information. So this is what the demo is signifying, that all your information is being logged using a single interface on your logging unit, on your logging node, and all of them is time synchronized. Thank you so much for joining in and paying attention to our demo. I wish that this was fruitful. If you have more questions, please feel free to ask us. Visit our virtual booth. And if you have further questions, don't hesitate to email us or contact us through any of the media that's mentioned here. Thank you once again, and have a nice day.